Federico Razzoli, database calling in from London. Good to see you again, Federico, and your bookshelf.
Great to see you, Kai.
So, temporal tables. You mentioned application time tables, and you mentioned system version tables, and you said you can combine them and have bitemporal tables. But why would I want to use which one of those, and why would I want to use both at the same time?
Okay, this is an interesting question because I believe they respond to different use cases. For system version tables, what you track in the temporal columns is when a row was physically inserted or modified or deleted. With application timetable, what you track is when a row is logically valid. So for example, I could insert a row now and decide that it will be valid in the future. Okay. So the difference is application timetables handle the timing when a row is logically valid, and system versioning tables track when a row is physically written or modified. And bitemporal tables are useful in cases where you need to track both the things.
So you could select country, president, group by country, and then you would get it for any particular moment back in history if you were using application time tables. Is that the case?
Yes, exactly. That's a perfect use for application timetables because if you insert data today, for example, of course, you cannot use system version tables.
And using them at the same time would be necessary because you want both functionalities, both that one of application time and system version. But what's the reason?
Yes, you can do it in a situation where you want your application to be able to handle time correctly from a logical point of view, but you also want to be able to track when the changes to the table happened.
And that you do for auditing purposes, or why do you want to track exactly when it happened?
Auditing purposes is probably the most common thing, because if you see something strange in a table, a row shouldn't have a certain value, or a row was deleted and you don't know why. Well, system version tables help you to kind of rebuild the history of each row and find out what happened.
So during this MariaDB Server Fest, we often compare MariaDB Server to other databases, and not just open source databases, but proprietary databases. So how do you, in the case of temporal tables, how does that comparison work out?
Okay, another great question, because there is a sort of idea that features in proprietary databases are always superior, which is not really the case, and temporal tables are a good example of this, because MariaDB implementation is more complete than SQL Server or Oracle implementation, which I believe, last time I checked, they don't support even bitemporal tables. DB2 from IBM supports them, to be completely honest.
Mm-hmm. So then I'm thinking of another common denominator here is looking at performance questions. So I would be surprised if there were no effect on performance, so it being slightly slower at least. But what's your assessment on the effect of temporal tables on speed?
Actually, in most practical cases, there is no slowdown, because as I mentioned during the talk, when you use system version tables, basically the final timestamp of each column is added to, for example, unique indexes and to the primary key. So basically, if those indexes are able to speed up your queries without taking account of the time, well, they will still be able to speed up your queries taking the time into account. And also something that I couldn't explain during the session for time reasons is that you can partition temporal tables, and you can actually put all the history into one or more partitions. So basically, even if your table is big, you are still able to query the current data and physically query only one partition.
Mm-hmm. So partitioning, you mentioned that. What about archival? So there'll be discussions about S3, and there's the old archive read-only storage engine. So how would you, where do the temporal tables fit in that discussion?
Yeah, so partitioning is useful also for this reason, because when it's time to delete the very old history of a table, you can actually delete one or more partitions, which is a fast operation. And you can move the data actually into S3 using the great S3 storage engine, or you can move them somewhere else. This depends, of course, on you. But the useful thing to notice is, again, use partitioning, because this will allow you to archive your data more efficiently.
Right. So we noted in most sessions here activity over Zulip. So in Zulip, there's a lot of discussion and questions. So did you get any interesting questions that you wish to highlight?
All the questions I got were absolutely great. And if I still have a minute or two, I will answer a question about the use cases.
2 minutes.
Okay, great. So yes, I am aware of at least a couple of use cases where I actually recommended customer to use system version tables. And the reason was that in both cases, the customer had to allow analysts to run queries on production data and see how this data evolved over time. So these customers were using MySQL, not MariaDB. So migrating to MariaDB would have been too much work for this, right? So what we did was adding a MariaDB replica and attaching it to the primary MySQL server. And in this way, the data was replicated, and the replica recorded the timestamps when the rows changed. The only drawback that I saw with this is when replication lagged, the timestamp was, of course, inaccurate. But in their use cases, this was not really a problem, and I suspect that in most real-life use cases, it wouldn't be a problem, because analysts usually don't need second-precise data, right? They want to see the trends over months or years.
Great, great use case. So thanks, Federico, for a good session, good question and answer session, and also highlighting an important question out from Zulip. Thank you, Federico.
And thank you. It's always great to participate to MariaDB Foundation's events.